Okay, sorry, I forgot to hit record at the very beginning, but I'll repeat myself a little bit. If they give me a force in newtons, I can convert it to an equivalent mass in kilograms by dividing by 9.8. And we said we're accelerating upwards, so that's our winning. Sorry for those of you on YouTube, I forgot to hit record at the beginning. How would I get the normal force by itself, folks? Pardon me? Plus mg, so Fn is going to be ma plus mg. Get your calculators out, please. What's m as a number exactly? 55. So as far as I'm concerned, I can give you the person's mass in kilograms. By the way, this is terrible. I just realized that there's a kilograms right there. Let me delete that. I was cutting and pasting questions this morning. I can give you a mass in kilograms, no problem. Or I can give you their weight in newtons. I'll probably do one of each on your test somewhere along the way. So make sure you read carefully. Please don't tell me the person has a mass of 539 kilograms. That's over 1,000 pounds. Unlikely. Okay? What do you get? So it's going to be 55. What's A? Times 3.6, the question told me, plus 55 times, what's G? 9.8. What'd you get? And the way you're going to participate, by the way, is on your calculator. Sorry?
737.
Normally, this person feels a gravitational force of 539 newtons. They're feeling now that they have that big a force, they feel heavier. And on the way up, if you're accelerating up, you will feel heavier. If you're accelerating down, you will feel lighter. Speaking of down, B. There's a part B as well. It says, what would the scale read in kilograms? So if I wanted the scale in kilograms, how would I convert 730 newtons into kilograms? Because most bathroom scales don't read newtons. I wish they did. They read kilograms. How would you convert that to kilograms? Kyla, what did you just type on your calculator? It's going to be really close to 73.7. What'd you get? 74? 75.2? So this person would feel as though they had a mass of 75.2 kilograms. They don't actually have a mass of that, but they would feel like they did while it was accelerating. What about once the elevator hit a constant speed? Good question. Let's come back to that. B, accelerating downwards. Accelerating which way, Cleo?
Down.
Which way is winning?
Down.
Which way is the longer arrow?
Down.
Good. Get the obvious one.
Gravity.
Which way?
Down.
Ooh, I think gravity is going to be the winner. I think in this case, the normal force is going to be the loser. Give me my equation, Cleo. It's always winner minus loser. Yep. Equals. Yep. I want to get the normal force by itself because it wants the scale reading. What's right in front of the FN that I don't like? This is what we've nicknamed the swappy dance, and I really would encourage you, draw an arrow there. You can even put a plus sign there if you want to let yourself know you're plussing that. Draw an arrow there. You could even put a minus sign there because we're minusing that one over. The mg just drops down. I have a minus ma. That equals the normal force. Now, normally, I would stick the normal force on that side by itself as a habit, but I'll leave it like this just in this printout so you know where it came from. Crunch the numbers. What do you get? M was 55. Sorry, I've scrolled down and you don't have that in front of you. M was 55. G is 9.8 minus 55 times 5.2. We'll make a little note here so that you have it handy because I'm scrolling down. What'd you get? 253. Anybody else? Yes? So this person would feel the ground pushing up through their feet with 253 newtons, and that's what all of you feel as your weight. You don't actually feel gravity. You feel the ground pushing up through your feet. How many kilograms would the scale read, Sahara? 25.8 kilograms. This person would feel less than half their weight, which actually makes sense because they're accelerating downward at more than half a G. You would be screaming if you were in this elevator because we don't deal with with lighter than normal very well at all. That's where you saw the kid freak out in the roller coaster video that I saw you. All of us have felt heavier than normal, but very few of us frequently feel lighter than normal. Let me pause. Are we okay so far? Now, Really, although I'm calling these elevator questions, no elevators accelerate this fast because they would be terrifying. They don't have 3.6 or 5.2. The elevator's pretty close to some of these, though. If you ride on it, if you have an accelerometer in your iPhone, you can actually measure it sometime. Or if you take Physics 12, you can choose to analyze that ride, and you can measure it sometime. We go on a field trip to Playland, and you can measure it. Most elevators accelerate very small, maybe 0.5 meters per second squared, but then they hit a constant velocity because you're not accelerating the entire time. They go up to speed, and then you can feel, you've all felt it, you can feel it through your feet. Oh, it stopped accelerating, now we're just moving. So if we're going at a constant velocity, moving downwards, what would the scale read? Well, let's try a free body diagram. Mark, what are the forces acting? Get the obvious one. Yep. What else? Bigger, smaller, or the same size as mg, and how do you know? How do you know it's the same size? So if we're at a constant speed or a constant velocity, that means A is 0, which means the forces must be, I'm looking for a word that begins with the letter B. And so you could just say it's a tie, which means I don't actually need to do the calculator question. I had it way up here. What was the mg of this person exactly as a number, Mark? The mg, don't say 55, that's a mass. And this is saying mg, this is a force. What was the mg exactly as a number? I'm putting the eraser around it so you can read it. What? 539 newtons. That's what most of you feel normally on an elevator, because elevators don't accelerate for very long. They go at constant speeds for most of the time. And you notice it doesn't matter whether it's going up or going down. Constant speed, A is 0, you'll feel the same thing. I would have said something about, this is why Isaac Newton said there's no experiment that can tell if you're moving at a constant velocity or at rest. We can detect acceleration, but once you're going at a constant velocity, can't detect it. Is that okay so far? Carter, that's elevator questions. If I wanted to take it one step further, I could ask you to find the acceleration, and if I was really mean, I would tell you what the scale was reading in kilograms. So here we have a 58 kilogram person. They're standing on a bathroom scale while inside an elevator. We're going to see if we can just draw a generic free body diagram and tweak it. If you're in an elevator, what are the forces acting on you? Marcella, get the obvious one. Yeah, you're with me now? I caught you zoning out. And there is a normal force up. I don't know which one's bigger, but I know that's the tug of war. Got me so far? What's this person's mass normally standing still? In part A, what's the scale saying their mass is? Do they feel heavier or do they feel lighter? Which way is the elevator accelerating in part A? That's the question. Loud and proud. Yep. And I'm hoping you've been on enough amusement park rides or had enough playground experience. Yeah, if you're accelerating down, you feel lighter. Which way are we accelerating then? Who would be winning? So for part A, I would go mg minus Fn equals ma. And this question is wanting the magnitude and direction of the acceleration. So I've already down. I got the direction part. How would I get the A by itself? So I'm going to get this. A equals mg minus Fn over m. What's the mass, Marcella? What's g exactly as a number? Minus, what's the normal force? Don't say 48. Why can't this possibly be a force? Yeah, it's not newtons. How would I convert 48 kilograms into newtons? It's equivalent in newtons. Mila. So it's going to be minus 48 times 9.8. Can I put the 9.8 in brackets instead of using the x? Divided by m. Which mass? Their actual mass. Yes. Can you all try that on your calculator? You're going to have to put brackets around the top. Don't need brackets around the bottom. Magnitude, and then let's remember to add the direction since the question asked for that. Down. Josh, what'd you get? 1.69. Anybody else? Yeah? Units, it's an acceleration, Josh. Newtons is acceleration. What? Okay, this is why at the beginning of the year I was yelling at all of you. It is worth memorizing what units go with what. So it's going to be meters per second squared. What was the direction, Marcella? Because they feel lighter. Okay, let's compare that with part B right here. In part B, this 58 kilogram person has the scale telling them that they have a mass of 71. I think, can we agree they feel what? Heavier. Which way are they accelerating? Up. Which way must the winning force be? Now, if this was a test, I would probably do a separate free body diagram for each question just to reassure myself. But Cleo, since I did kind of a generic one where I made the arrow lengths the same and I'm just imagining the arrow lengths changing, in my homework, Allie, is probably how I do it, I think. Allie, which way are we accelerating in part B? Which way is the winning force? Who's winning? So I'd have this. Normal force minus mg equals ma. Get the a by itself, divide by m. Do you notice how similar these two equations, this is why I said to you, Carter, there's only going to be really a few mathematical operations we're doing. It's going to start to look fairly repetitive. I have a equals, how would I calculate the normal force? It's going to be what the scale reads times 9.8, or I could have given you the scale reading in newtons already, in which case you wouldn't have needed to multiply by 9.8, but I gave it to you in kilograms, minus 55 times 9.8 divided by, 58 times 9.8 divided by 58. All of you, please try typing that in. If you cannot type these in, you need to see me at a separate time, and I need to teach you how to use your calculator. But hopefully, Jack, we're at a stage now where this is pretty good. Allie, what'd you get? Cleo, what'd you get? Anybody else? Was it 2.19? 2.1? Rounded off properly? 2 point. Okay, by the way, if someone doesn't round off properly, make sure you all speak up. 2.20? Yeah. Allie, you got that okay? Yeah. Meters per second. What was the direction? Up. Okay. C, we can do in our heads. What's the scale reading in part C exactly, AJ? What's this person's actual mass? What must their acceleration be exactly as a number? So they're either going at a constant velocity or they're at rest. I don't know. Albert Einstein would have mentioned something about that. But I can tell you that they're not accelerating. So C, A equals 0. What about D? If he reads 0 kilograms, I can tell you exactly what his acceleration is as well because I've experienced it. 1.8. He's in free fall. Has to be in free. That's the only way this is possible. So in this situation, the elevator cable has snapped. Sorry. Or in my situation, I've mentioned I jumped out of. I would have been jumping out of an airplane. Okay. And that's why I said to you, that explained why the astronauts float on the International Space Station, not because there's no gravity, but because there's no normal force and they are in free fall. That's just nerd trivia. If you take Physics 12, we look at rocket science. My Physics 12s are just starting to dip their toe into the world of rocket science. So 9.8 meters per second squared down. Gotta be down. Is that okay? Tension questions. It's probably going to be some tension questions. So a rope is attached to a 6 kilogram rock and pulled. Find the cord tension. You know what? This is a job for a free body diagram. What are the forces acting on it? Get the obvious one. Which way? Down. What else? Tension. Which way? Mr. Dewick, Is this going to be really, really similar to this physics here, except instead of a normal force, it's just going to be a rope force, which is tension? Yeah. Did I mention, Carter, that a lot of the operations are going to start to seem fairly repetitive? Good. So there's my generic free body diagram. I'm not worried about arrow lengths yet. In A, what's our acceleration? 0. So the forces must be. So you know what? I can tell you what the tension has to be exactly. It's got to be that. Can you go 6 times 9.8 for me, please? $58.8 newtons. Okay? Remember, an acceleration of 0 means this is either at rest or it's at a constant speed. I don't know. One or the other. What if we are accelerating? I can save some space. What if we were accelerating up? Who would be winning? In my free body diagram, who would be winning? Hello, who would be winning? Can you say that with authority and confidence in your voice? I heard somebody say, tension. I like what Mila's going, tension. Yeah, like you're feeling right now, tension. And then it would be minus mg equals ma. How would I get the tension by itself? Which is what? Can you go 6 times 6 plus 6 times 9.8? I have no idea. Sorry? 94.8? Yes? Newtons. If we were accelerating down, which force would be winning? Gravity would be winning? And I think tension would be smaller. Let's find out. Now we're accelerating down. Let's see if I can kind of keep this on here. I think I can if I take a bit of space. No, I can't do that now because I got writing rats. Who's winning? Gravity? Who's losing? Tension. What's that equal? Ma. Carter, what do I want to get by itself? What's right in front of the T? Swappy dance time. And you'll get mg minus ma equals tension. M was 6. So you're going to get tension equals 6 times 9.8 minus 6 times 1.5. And again, we don't need to make that 1.5 negative, even though it's down, because we've taken care of that in our equation. What do you get? 49.8 newtons, which is smaller than this answer. By the way, that also means, question, is the rope more likely to break when you're accelerating it up or when you're accelerating the mass down? When is the rope more likely to break? Where was tension bigger? Up, yeah. And it's kind of Captain Obvious. If I'm going to make a rope break, it's if I yank up on it, not if I suddenly give it slack. But it's nice to know that the obvious physics also works properly. It means the obscure stuff, I think, works as well. Okay? Okay. In the previous questions, I gave you the acceleration, and I said find the tension. Here, I'm giving you the tension, and I'm asking for the magnitude and the direction of the acceleration. Well, my tug of war is going to be between, get the obvious one, and tension. I'm not sure which arrow's longer, Hayden, so I drew them the same length, but I'll imagine one of them, I think, will be longer, maybe? Is that all right? It wants me to find the acceleration. Who's winning? I don't know. How can I figure out who's winning?
7.5 by 9.4.
First of all, how big is tension exactly as a number? 62. Remember that. How big is mg? Crunch it. Figure out how big mg is. 70, even? 73.5. How big is tension? 62. How big is mg? Who's winning? Gotta be. I might even do that now just to remind myself that I figured that out. And now I can go mg minus tension equals ma. Must be accelerating down because tension's smaller than mg. How would I get the a by itself? Divide by m. So a is going to be 7.5 times 9.8 minus 62. Do I need to multiply that 62 by 9.8? No, it's in newtons. Divided by 7.5, which is, I have no idea. (1.53) meters per second squared. Now let's talk about friction. So the key concept for friction, it's mu times the normal force. So example 5 says this: a mass of 55 kilograms is being pulled to the right across a rough floor with an applied force of that. If we imagine our free body diagram, really what we have is a box sitting on a floor. I'm going to get rid of that. I'm just going to represent it with the dot. What are the forces acting on this box, on this mass? Get the obvious one. Is it sinking into the floor like quicksand? Is it flying to you like Superman? I think here the normal force is the same size as gravity. We have an applied force, and it says rough floor, so there is friction. This isn't asking me to find the acceleration. This is asking me to find the coefficient of friction. Okay, what symbol is the coefficient of friction in my equations? It's a Greek letter what? We're going to get the mu by itself. Okay, we can do this. Kyle, in part A, what's our acceleration exactly as a number? Who's winning? What's our acceleration exactly as a number? So the forces must be, I'm looking for where it begins letter B. So who's winning? It's a. So I could say this: F applied equals friction. I'm going to get the mu by itself in a second, but look at part B. Kyle, who's winning if we're speeding up? F applied, yes? Is that what you said? Minus friction equals ma. What if we're slowing down? Who would be winning? Friction minus F applied equals ma. I think those are the three possibilities. For all of them, friction is what times what? I don't know the normal force. Oh, but look. Because there's no extra vertical forces, for all of these, I can say friction is mu mg. Only mu times the normal force, but the normal force is the same size as mg. So in part A, I get this. F applied equals mu mg. Kyle, it wants me to find mu. How would I get the mu by itself? I'm going to get mu equals F applied over mg. It's going to be 200 divided by 55 times 9.8. I got no idea. .371. And remember, mu, no units. In B, it's going to be F applied minus mu mg equals ma. What am I trying to get by itself, Kyle? What's right in front of the mu that I don't like? Swappy dance. Carter, have I mentioned that you're going to find you're repeating the same mathematical? Okay. That's going to go there. That's going to go there. I'm going to get F applied minus ma equals mu mg. How would I get the mu by itself, folks? Again, divide by mg. F applied was 200 minus m was 55. A is 1.5 divided by 55 times 9.8. This is a good one to practice because this is reasonably complicated typing. Brackets around the top and around the bottom. You get 0.27. Cleo, would I round that off as a 7 or would I round that off as an 8? Darn right, right? No sloppy rounding next time. Good. What if we're slowing down? All that means is friction's winning. Don't panic. Fine, friction's the winner. It's still going to be mu times the normal force. I don't know the normal force. Oh, but look, mg minus F applied equals ma. What do I want to get by itself? How? What would I do first? I'm not going to divide by mg yet. What would I do first? I'm going to plus F applied over. Is that okay, Hayden? Then divide by mg. Can I do that in one step? Are you okay if I do? Good. Even if you're not, I'm going to. I think mu is going to be not mg, ma plus F applied, and then divide by mg. What was m? 55. A in this question is 2.2. It's slowing down, Mr. Dewitt. Don't you need to make that negative? I did that. I took care of that in my winner minus loser shtick there. So we're good. Plus F applied was 200 divided by 55 times 9.8. Which is what? Cool, what'd you get? 0.596? Okay. Also, as far as I'm concerned, for these same questions, instead of giving you the acceleration and saying get the mu by itself, I could give you the mu and say, what's the acceleration? You might need to figure out how big friction was to see whether it's bigger or smaller than the 200. In other words, you might need to calculate friction to see who's winning. Okay. Then you would know how to set up the equation. Car questions, dragsters. It says find the acceleration of a dragster if its tires have a mu of 0.12. What does this want me to find? The acceleration. Is there friction in this question? This is a job for a free body diagram. What are the forces acting on the dragster? Get the obvious one. Hello, get the obvious one. Works better if you all kind of participate that way. I know I've been talking a lot. What else? Normal force, ground pushing back up. What else? Well, if the dragster is accelerating to the right, I know there's a force pointing that way. Which force is that? Not yet. And Cleo, I'm kind of glad you made that mistake. I'm not, but I am. That's the most common mistake. In fact, that's the one I think I told you. I was at a conference and the physics teacher was trying to say that there's not an F. If there was an F applied, you could drive on ice because there'd be some magic force that was pushing the car forward. What is it? Yes. And that's it. Also, when you're braking, it's the same free body diagram, but friction's just pointing backwards because it's slowing down. In other words, for a dragster or a car speeding up or a bike pedaling, for all of them, friction is what's making you accelerate. Friction is what times what? Mu times the normal force is what's making you accelerate. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. Lillian, which one? I caught you zoning. Which force is the same size as the normal force? Good. What's kind of cool in this question is, for what it's worth, The mass cancels. A little Austin Mini and a big truck and the dragster, as long as they have the same coefficient of friction, they'll accelerate the same. A equals, it looks like, mu g. It's going to be 1.2 times 9.8, which is what? And it's an acceleration, meters per second squared. Right? Meters per second squared. Okay. I'm looking at the clock. I wanted to do number 7, but I'm not going to have time. So we're going to go like this. I'll get to number 8 here. Number 8 wants you to find the acceleration of the cyclist. But if you look at the question, Amy, did they give me a V initial? Yeah. Comes to a stop. Did they give me a V final? Yeah. Did they give me a distance? Am I going to use forces to find the acceleration, or am I going to use kinematics from before Christmas? I think kinematics. And so I think to find the acceleration, I would use A equals VF squared minus VI squared all over 2D. It's VF squared equals VI squared plus 2AD. Get the A by itself. I would have made my list, but I'm cutting corners, Jack, because I want to make sure I get through everything. I would have gone A equals question mark, VI equals VF equal, but VF is 0, VI is 21, all over 2 times 25. You're going to get a negative answer, and the reason you're going to get a negative answer is before Christmas, negative slowing down did mean negative, so I'm not going to freak out about the negative. I'm going to smile. I'm pretty sure I did it right. What do you get? 0 squared minus 21 squared divided by 2 times 25. How about divided by, Mr. Dewick? Negative 8.8. Wow, that worked out nice. Negative 8.82, you said? I'll keep the negative in my answer, but I don't think I'm going to use it when I get to forces. What it is telling me is we're accelerating to the left. We're slowing down. Winner is to the left. B says, find the coefficient of friction to bring her to a stop. This is a job for a free body diagram. Now I'm going to go forces because it wants to find a mu. I have normal force. What else? Oh, let me pause the video for a second. What else if we're dragging our foot to come to a stop? Which way? And again, is there an applied force pointing forwards? No. Who's winning? Got to be friction. Who's losing? It's a trick question. Who's losing? No one. Friction equals MA. And we're going to use our answer from the previous question. This is why I've said to you, as far as I'm concerned, all of the pre-Christmas kinematic stuff, Amy, is fair game as well. I can give you enough information that you can find the acceleration and then move into forces and do something with it as well. Friction equals MA, mu times the normal force. I don't know the normal force. Oh, but look. I know the force same size as the normal force. Kelvin mg equals MA. Turns out the mass cancels. You don't have to if you're not sure, but it does cancel out. And I get mu equals A over G. It's going to be 8.82 over 9.8. 0.9 even? That's a total fluke. Units? All right, none. What if that's not enough mu to bring yourself to a stop? Are you going to crash? No, what you do is you push down. If you were to push down, what would happen to the normal force? Because you're not sinking into the ground like quicksand, you're not flying. You would make the normal force larger. What would happen to this? This would be not mg, it would be a bigger number right there, and you would actually find that you can stop quick. You can stop quicker. You get a better acceleration, bigger acceleration, deceleration. Anyways. I'm going to skip number 9 because I don't know if I have time. We kind of did one like that. Number 10 is so easy that it's tough. This is from your homework. I gave you this question. It says the race car below has I changed the numbers, has a mass of 940 kilograms. Find the tension in the rope if the parachute is decelerating the car at 4.2 meters per second squared. I realize this is find the tension. This is not a winner minus loser gravity mass moving up and down on the rope, but it does want us to find a tension. Michaela, you know what this is a good job for? McKenna, you know what this is a good job for? I'm tired. On what? The car. What are the forces acting on the car, McKenna? Get the obvious one. Yep. What else? What else? Well, I know the car's slowing down, so there has to be a force in that direction. What force is that? Friction? Well, what? It's the parachute, but really, this is why we added that right there. It's a rope. It's the force from the rope, which we call, you're right. Do you see why I meant this is so easy that it's tough? Who's winning? Who's losing? It's a trick question. There is none. What does winner minus loser always equal? It's going to be, that's how big the tension has to be. No need to bring in friction, no applied force, no. When you pull a parachute for a dragster, tension is what's slowing it down. And by the way, you said friction, if it was accelerating, friction would be what's making it go forwards, but I would almost guarantee right now he's neither touching the brakes nor touching the gas, so the wheels are just turning freely, and so between the wheels and the road, no friction right now. That's why that's the free body diagram there. Is that okay? What do you get? 948. So if I go to 3 sig figs, which is probably what I would do on the test, and tension is a force. Good, Jan Mila? I've talked a lot, I know. One more. This is our last one. I think I can get rid of some space, though, Mr. Duick. Why is this question so much tougher? There's an extra vertical force in the equation, that little arrow there. I'm going to give you a question, at least one, maybe two, where there's an extra vertical force. What that means is the normal force is not mg. The arrow might be pointing up, the arrow might be pointing down, and I'll just write a number next to it. I took this right from the homework, and that's all I changed. And it says, find the acceleration. This is a job for a free body diagram. Although, did they give me a picture this time, Kieran? I'm going to label the picture. You okay with that? Okay. Here we go. Everybody, what are the forces acting on this? Please get the obvious one. Everybody. Is there an extra vertical force in this equation? Normal force is not mg. It's going to be weird. Now we got to think carefully. Is the normal force going to be bigger, smaller, or not the same size as mg? I've already eliminated that. Is the normal force going to be bigger or smaller than mg? Well, someone is lifting up with 14 newtons, so the normal force isn't having to cancel out all of gravity. So is the normal force going to be bigger or smaller? Smaller. And I'm going to exaggerate it so it catches my eye. Then I have this 44, which we've typically called the applied force coming from off the page. And since there's a mu, there is friction. Who's winning? Let's guess the applied force. If we get a negative acceleration, we'll know we've guessed wrong. Who's losing? Friction. What's that going to equal? MA. And they want me to get the A by itself, so I'll probably do that. I am going to get F applied minus mu times the normal force, because that's what friction is. But I can't use my standard, I don't know the normal force. Oh, but look. I'm going to have to figure it out. and I'll figure it out by saying, since we're not sinking into the ground like quicksand, we're not flying into the air like Superman, everything up has to equal everything. Finish the blank, folks. Good. So everything up, normal force plus 14, that's everything up, has to equal everything down. How would I get the normal force by itself? So wherever I see a normal force, I'll replace it with mg minus 14. It's going to go right there. I'm going to get A equals F applied minus mu mg minus 14 all over m. M is 4.5, G is 9.8. Let's see if we can type this in one step. It's going to be open a bracket, 44 minus 0.74, open another bracket, minus 0.74, open another bracket, 4.5 times 9.8, take away 14. Close off that small bracket, close off the top, divided by 4.5. I made these numbers up. I'm really hoping I get a positive answer that applied is winning. Do I get a positive answer? Ha ha! I do. 4.83? Okay. Now, if you don't want to do this in one step, Lillian, you could crunch this and then put the answer button right there when you're typing. Or I can show you how to do this in one step. The only thing I didn't do is find the mu when there's an extra vertical force, which is really tough. But folks, that's a quick review of everything that we've done up till now. That help? I hope. Okay. I'll upload this as a video, and then what I'll do is I'll email this to all of you as an attachment. I'll also print up copies for you as well, but that way you have a digital copy. There's about 4 minutes left. Oh, hang on, I got one more. I stand corrected. I did do one nasty one. Quiet, please. Focus in. Hey, I got 3 minutes. I'm going to go through this really fast. They want me to find the mu. We're accelerating to the left. This is about as tough as I can ask you. What are the forces acting on it? Get the obvious one. Gravity. There's going to be a little small normal force because 100 newtons is already being taken care of by gravity. There's going to be F applied. There's going to be friction. We're accelerating to the left, so who's winning? Minus F applied equals ma. I'll get mu times the normal force minus F applied equals ma. I'm trying to get the mu by itself. Mila, what am I going to move over first? I'll get mu times the normal force equals ma plus F applied, Mr. Dewick. And then I would divide by the normal force. Now the problem here, I don't know the normal force. I would have to calculate it by going everything up equals everything down. How would I get the normal force by itself? That's the number that would go down there. I don't have time to finish this completely. I can also tell I'm losing you folks. I will really quickly just crunch this so there's an answer. What was M, Mr. Dewick? 50 times, what was A, Mr. Dewick? 1.8 plus 55 divided by bracket 15 times 9.8 minus 100. I'll fill that in later.